to a podcast. Welcome
Before
back.
We start.
Yeah.
The funny thing is, from the text when I read it, I saw Department of Corrections, and I was thinking we were going to talk about jail and like overcrowding and racism and
it's just
racism.
They don't know what I know.
Welcome back to another Zengineering Podcast. I'm Adam.
I'm Brian.
I'm Alan. I'm going to be a guest on this show today.
Sweet. You're the first guest to like own a piece of that beyond just saying your name. I like it.
Welcome, buddy.
Thanks, man. Good to see you guys.
Same.
So Alan is another good friend of ours from way back.
Many
We
years
were
ago.
talking about this beforehand. You're a software programmer by trade.
That's how I spend 40 hours a week,
You spend 40 hours a week.
at least.
But I've been particularly stoked to get you on as a guest, in part because I really don't think the podcast would exist without a lot of the interactions that we had during our like developmental years.
I gotta say, I have often listened to this podcast just to pretend that like we're on a couch somewhere.
Like I really think
That's awesome.
I think of specific interactions frequently that resulted in me being a more interesting person. Like, I don't even mean like, oh, you taught me how to work a recorder. Like, everything I know about like improv is because of games you brought back from college.
You're definitely one of those friends, Alan, that when I think back about our interactions as kids, your like character and personality age really well in my mind. Like
Ooh,
you get
thanks,
more
man.
and more interesting, and I'm like, damn, that was more, every little like memory, I'm like, that was even more valuable now that I have perspective on it.
That's high praise. I'm glad to hear that.
I was trying to think of a good story, and the one that came to mind was the time we were in the classroom where we all had English senior year. We all sat at a single, very large table, and there was one time when our teacher knocked over a giant thing of coffee directly across from you on this big table, and you, in one fluid motion, grabbed the bottom of your sweatshirt, whipped it off inside out and onto the spill before anyone else knew what the hell was happening, and like contained the spill, pulled it back, and it was completely gone. And everyone just went, and you were like, it's just a sweatshirt. I'll put it through the wash. And I think of that frequently when I'm like, I'll just use my sleeve. And someone looks at me like, what? And I'm like, clothes exist only primarily to keep dirt off of us, which I think is what you said afterwards.
You know, my dad would always cut out articles from Esquire magazine for me, I think in an effort to make me at least a little cool. And I remember clearly that one of them, I don't remember any of the context around this, but it said, you will be a happier person if you consider all of your shirts to be ultimately disposable.
That's a great quote.
I think that's like, let's just end the podcast right there.
All right. Good being here. Nice to see you guys.
No, the real place to go with it would be to talk about, you know, the value of t-shirts for demonstrating your...
Oh, that phase of my life is over.
I have a specific shirt and like specific pictures of me that are on Facebook that come to mind when you say something like that. And I'm like, I cringe at the thoughts of like what I was wearing and what I was thinking and like the goo I put in my hair and stuff at the time.
Was there a slogan on the shirt that you're thinking about right now?
There's an important thing to understand here. We went to a prep school where you had to wear a dress code all day. So we didn't have the freedom to pick our own shirts, but for the summer and after school hours until we were like 18.
And those t-shirts you wore underneath your dress shirt.
Right. That maybe people would see after school when you unbuttoned your shirt, which was definitely an Alan Gilbert move. So I thought we'd start this one off with, well, you said you have corrections. Should we start with the corrections?
I came with two gentle corrections to make.
I love it. You'll have to introduce the episode as well.
Yeah, so I actually was about to admit I did not go back and listen to the particular things that I'm going to correct. So episode 3, I believe, was about quantum computing.
Sounds right.
I love this.
So at one point, Kerp, you were excited talking about how cool quantum computing is. And one thing you said was that a quantum computer has a 3-digit representation of information, or not three-state representation of information, as opposed to a regular computer, which has a binary two-state storage of information. That's not true in that's not true. And there are two interesting things to say about that. One is that ternary computing, which it would be a computer where instead of a bit has a 0 or a 1, it has 3 states that it can represent. The Soviets, back when, we were developing rockets, they were developing rockets, we were developing computers, they were developing computers. They had the same caliber engineering schooling as we did, and there was no interaction between the two communities of scientific development. So they wound up making these ternary computing devices that used this sort of base 3 numeric representation. And they used in it this balanced ternary notation, which makes certain parts of computing much easier and more straightforward to implement. But it's a huge pain in the ass to make these 3-state transistors, whereas we were cranking out binary transistors for pennies, right? Theirs was a much more convoluted manufacturing process. And so ultimately, binary computing won out because there is no real theoretical difference between binary and ternary computing. They have certain different strengths and weaknesses, but there's no real reason to prefer one over the other, except that you can crank one out for pennies per transistor and another out for potentially dozens of rubles per transistor.
So dozens of rubles. So do you have do you know off the top of your head some of the things that made it different, that were easier or were simpler?
Yeah. Been a long time since architecture class in college, but representing negative numbers in a binary representation just cuts in half the range, right? So if you have 1 byte, you can represent 255 possible values. That can be 0 to 255, or negative 127 to 127, approximately. I'm off by 1 there somewhere. Because you just need this first bit to, my math isn't working out.
That's okay. We'll have a correction.
Yeah, I'll come back. I'll listen to this later.
Wait, but you're saying you lose a bit to the fact that you have to designate that it's a negative number?
Yeah, there's 1 bit that's is this a positive number or is this a negative number? Whereas in ternary representation, each digit, so there's a lot of ways you could do this. What they did was they used balanced ternary representation of numbers, where each digit was either -1, 0, or 1. And so what you'd do is you'd go, should we break in for a second to talk about different bases of numbers, or is that too deep into the rabbit hole?
Let's do it.
Yeah, let's do it.
Okay. When you talk about base n numbers, we count in daily life in base 10 numbers, right? Any slot in a number can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we all know how that works. You have the ones digit, then you have the tens digit, then you have the hundreds digit, and the position of a given number or of a given digit matters. And some of them are worth a little, some of them are worth a lot, and they go up as powers of 10. In binary numbers, which are used by computers, each digit is worth twice as much as the 1 to the right of it. So you have a 1's place and a 2's place and a 4's place and an 8's place. If you think about tallying, right? You're a prisoner in some dungeon and you're just etching on the wall how many days you've been there. That's the sort of degenerate case of this. That's base 1 counting, where each digit is worth 1, right? You only have 1 digit and it's 1, and either you write it down or you don't, and then you just count them up.
When you said degenerate, I thought you meant the guy in the cell.
Me too. Me too. And I've never thought of that as being base 1 before either. That's really interesting.
Why not
both?
I'm going to claim that. That was a pun. It was intentional. I thank you for recognizing it. And then another way on the other end of the spectrum is sometimes you need to cram just a ton of data into a web address, right? Zengineeringpodcast.com/, and you want like just a ton of data in the next like 5 characters. What people will often use is Base64 encoding, where Base64 is you have all the lowercase digits, all the uppercase digits, and all the lowercase letters, all the uppercase letters, and 0 through 9. And then they like eliminate a couple of them because like 1 looks like L, looks like capital I, that sort of thing. And so what you get is a 1's place, a 64's place, a like 1096th place, maybe. I mean, like those numbers gets big fast. And so in just a small number of digits, you can represent really huge numbers.
And so what you just described, it's how specific you can be with the piece of information in that slot, or
it's
like when you say it's in a digit.
Think about why we have these systems of representing numbers, right? Numbers are some sort of concept, right? Like I have 312 sheep, like that 312 does not exist on paper, but I want to write it down. And so I have a couple of options. One, I can draw a tiny sheep 312 times and then hand it to you, and you can count all of them and be like, oh, he has 312 sheep. Or I can save us both a lot of effort, and like we can decide on this larger vocabulary of basic numbers that we can put down, right? 0 through 9. And I can write 3, 1, 2. And you probably don't do this math, but ultimately you could do this math where you could say, okay, that's 2 plus 1 times 10 plus 3 times 100, right? And that's the number of sheep that I have. If we're doing like base 312, right? All you would do is write down the 1 digit that represents 312. And the reason we don't have a base 312 system is none of us could, it'd be like learning to read Japanese. Like you just need to know thousands of characters before you could count to 10.
Yeah, it
right?
kind of seems like base 10 is like an optimized compression algorithm for the human brain to packet up little chunks of counting and be able to relay them to each other. Right. And there's Alan's holding up his 10 fingers, his 10 digit right now.
You ever heard Johnny 12 Toes off of the Schoolhouse Rock albums? It's about how if we had 6 fingers on each hand and 6 toes on each foot, we might count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, do, dec, L. Right?
There are this is a
Yeah,
really
L
interesting
toes.
topic because there are civilizations that have developed with different bases, right? Didn't like the Aztec, didn't they do everything in base 20 or base?
I think it was probably base 12, or I don't know. I shouldn't run my mouth about that sort of stuff while I'm trying to correct you.
That's what I'm trying to do, actually, is trip you up so that the corrections become meaningless. Not only to worry about them.
That's probably answers the question I wanted to ask after that, though, which was like, so if an alien race developed along the same timeline that we did and developed computing like we have, but they had 6 digits on each appendage, do you think would their computers be better than ours?
No. In a theoretical sense, no, not at all.
This brings us full circle to what you were saying
right
earlier.
And that's why I wanted to call this out, because ultimately this is just a different way of representing information. What's cool about quantum computing is, and I'm not going to try and explain what a qubit is because I definitely do not really get that stuff. But a question that computer scientists often ask is it possible for a computer to compute an answer to this question, right? How many sheep does Alan have, right? Can the computer get that answer? Yes, it counts all the sheep. Some things are easy to calculate quickly. What's the size of this list of things? Some things are a little harder, right? Can you take this list and sort it, right? That'll take, for a short list, you can do that fast. For a long list, you can do that less fast. Some things, like will this computer program ever terminate, cannot be answered. And so in that middle group, there are a number of classes of difficulty. And one of them, which is basically all of the problems that we can currently solve with a computer, like that we can realistically hope to solve with a computer. The reason I wanted to call this out is that the interesting thing about quantum computing is not that we have like this sort of deeper number system to draw on. It's that quantum computing can, in a sense, try more or less an infinite number of things at a time. So whereas a computer that we have now, if you want to say crack someone's encryption password, right? You'd have to try, see if their password is 123, then see if it's 234, then see if it's ABC, then see if it's DEF. A gross simplification is that a quantum computer could basically try all of those and report back if any of them worked and tell you what that one was. And so that's what's crazy about quantum computing is like we have encryption right now. Like I'm encrypting files on my hard drive. And what I've done is I've chosen a random number between 0 and 10 trillion, right? And if you want to figure out what's on my hard drive, you have to guess that number.
So then what Jones was saying about it is still correct in the end, which was the idea of what's so crazy about quantum computing is how much more powerful it is, that it's like, oh, passwords? Yeah, those are gone. Those aren't a thing anymore because now we have a computer anymore. That just blink.
Well, that was
all of them.
That was a funny episode because it was our third episode and Kerp like really wanted to do quantum computing and I did a lot of reading up on it and my conclusion was I don't understand anything that I've read. Essentially, Kerp's response to that was
using wrong
no way,
terminology.
man. You work with computers all day. I'm sure you understand the like 50 articles you just read, so we could do this episode. So we started, and I just couldn't answer anything. And so, like with a lot of our initial episodes, we were like arguing a lot. And Kerp's like, "It doesn't matter if you don't know that. Just say something." Which in the end, I feel like has been the right direction. But the only piece I knew when
doing a lesson I learned from Alan.
Cracking passwords, it could crack passwords much quicker. Do you have other like conceptual? That's not a very interesting application for like the average person. I think. Do you have something more conceptual that?
So one really hard problem that computers solve all the time, and they're solving them, you know. What are we using? 6 computers between us right now. We're probably doing this 3,000 times a second, I'm guessing. More, maybe, I don't know. Is a routing problem, right? I am speaking into my microphone at my laptop here. It needs to go out into the internet and find its way to both of y'all, right? Mm-hmm. There are effectively infinite ways that it could go from my computer to you. What's a fast one? What's the fastest? So the question is, like, my computer needs to communicate with both of y'all's computers. What's the fastest way to get that information there? And that's a hard problem. Like, that's a routing problem of, like, where should this packet go next? And you have all sorts of incomplete information and, you know, you have data about what has worked recently, but things change, lines get cut, lines get full, like that sort of thing. And so,
you mean cut like physically a wire somewhere?
Oh, yeah, it happens.
Split. And so the grid is weaker in that portion. So sending traffic toward it would be less
you
than,
need to route around that.
It's not optimal, right?
Well, it just like if there's a big accident on the highway, Google needs to send all those drivers around that. Right? They need to like route around that.
Yeah.
And so routing is a problem that is, you know, just really intensive. You just have to try a bunch of things and like you can make intelligent guesses or you can make dumb guesses. But like, even if you're making really good guesses, you have to try a bunch of stuff. And so quantum computing is an area where any given router in that network may well be able to sort of, instead of looking at all of these different requests that are coming into it and all of their declared endpoints, it can just look at all of them at once and handle all of them at the other end. And you know, it's a different kind of capability than what what we consider computers.
So I've got a weird. I was just picturing. Have you guys seen the videos of? I forget what they're called. Liechtenstein. Liechtenstein is like the lightning strike, right? When someone gets hit with lightning, they get Liechtenstein.
Like that fractal
thing on them, like this fractal pattern of lightning, the lightning traveling through their skin. And I was picturing that on a wet piece of wood. I don't know if you guys have seen this. They'll set up positive and negative on both ends of the wood, and
Lichtenberg.
Good third correction. And they'll send the current through the piece of wood, and you'll see that happening, and you'll physically see the electricity trying to find the quickest path through the wood. And as soon as it does, everything else like disappears and there's a flash and poof, it chooses the quick one.
That's actually a really excellent analogy. That's a phenomenal analogy for what's awesome about quantum computing. And thinking about sort of this like structure of tendrils, like branching out and trying to find the path to ground. And then as soon as like that connection is made, the whole thing just sort of collapses into that best path. So right now we have the ability to make parallel computers, like graphics cards are parallel computers for a very specific class of problem that you're trying to solve. But we have to manufacture this really elaborate hardware that can solve one particular kind of problem in this sort of massively parallel way. Quantum computers will allow us to, if you let me push an analogy a little far, I think maybe, define those massive parallel searches in software, which means you buy one computer and it can do like parallel solutions to all kinds of different problems. And you can sort of, without having access to a factory or a matter replicator, you can build that kind of parallel search that will try everything and then collapse on the correct solution.
As I was imagining that, I was thinking that there is a deeper thought here with the universe and how the universe is calculating its own future through that particular visual representation of something that usually happens, A, where we can't see it, and B, at a pace which we can't really record it or measure it. And so to see electricity flowing, because when you're taught about electricity, you're kind of taught like it flows from here to here, and unless there's like a closed circuit, unless there's a clear path, unless you have like two wires touching, it doesn't go anywhere. And that never jived with me when I was like taking physics. I was like, well, it has to do something to know that there's somewhere to go, to even try to know, to even try to go somewhere. And when you see that in a physical thing moving, there's so much going on in like the intelligence of the universe of those little electrons trying to get across that board. And
exactly that same thing happens when regular lightning strikes the regular ground. It just happens on a time scale much, much, much faster than.
Yeah, good point. Yeah, that's exactly what's happening in the sky.
Fungus and roots and like
at a time scale that's difficult to observe for the opposite reason.
Opposite, totally. That's another great analogy there, Kerp.
Because you cast out a bunch of roots and then one of them gets good and fat because it's tapping into, groundwater or whatever.
Send more that way.
The scene in Jurassic Park with the really tall guy who has really peculiar personality. What's his name? He's like the chaos professor, and he's dripping water on her hand. Anywhere you have fractal patterns, it's the universe trying to figure out its direction. What direction should I take, and how do I get there? And I'm computing all these calculations at once to try to figure out where I should be going.
Incidentally, I feel like this is exactly the same conversation we had on the way to that Tom Petty concert that disturbed me so much that exactly what we were just talking about, the fractal progression of nature. I was so in my head that we left the concert early. I was just like, I can't do music right now. Can we walk home and just keep talking about this stuff?
Kerb and I were like raging while we were waiting in line to go into this concert, talking about how excited we were, all these things about fractals we had just been reading about. I don't know if we just shared a bunch of articles with each other or not, but all the people around us, Kerb, we were a little fucked up, and so we're in line and we're like talking really loud, and Kerb's like, dude, you're freaking everyone out. Like, we can't be talking about fractals this loud. And so for the next hour, as we like make our way in through the crowds, we're standing in line, like we're both a little uncomfortable and nervous, and Kerb thinks everyone's like listening and judging, and they're like, what are you talking about? So eventually we just lost it, and Kerb's like, we got to go. Tom Petty, sunset coming down over the mountains at the Hollywood Bowl, and Kerb's like, we got to get the fuck out of here. Can't handle this.
I forgot we also went to a Tom Petty concert, though.
Yeah,
is that what you were thinking of?
I thought you were digging deep.
So that was correction number one.
That was correction number one. I have another minor correction. You're talking about encryption.
Yeah.
Brian, you said you were giving some examples and you said, I guess even like if you zip a file and compress it, that's a form of encryption. Emphatically, no, that is not a form of encryption. That's an encoding. And the difference is, if I know exactly how you compressed that file and I get a copy of it, I can decompress it no problem at all. Whereas, even if I know exactly how you encrypted a file, unless I know the secret numbers that you used to encrypt it, like the key, I would not be able to decrypt it. There are a lot of really deep similarities between compression and encryption, but I had this coworker who just like always insisted that like we don't have to worry about people like phishing all of our credit card numbers out of our database because we lightly encrypt them, or like we partially encrypt them. And like, these aren't real concepts and they don't exist.
Well, wait, I want to dig into this one a little bit, because I'm glad you brought that one up in particular, because I remember saying that. I remember thinking that actually at the moment, and it was like sort of a semi-epiphany. I was like, I even think that's encryption. You had a caveat there when you started out. You said, if I know how you encrypted it, if I know how you compressed it, if I know the process or the algorithm. And so if zip wasn't like a standard program and a standard algorithm that was available on every computer, wouldn't that be the same essentially? Isn't like the pattern by which you compress it the same as an encryption, like a password?
How hard is one to guess versus the other? I feel like is really is that the question?
The real difference is, ultimately, if I decrypt one of your messages, you need to like go back to square one and come up with a completely new way of scrambling these messages before you can trick me again, right? Before you can hide things from me again. Whereas if it's an encryption algorithm, if I somehow come up with your secret password, that moment, like that minute, you can just be like, oh, here's a new password, right? Like generate a new 4096 bit encryption key, and let Alan try and guess another number between 1 and 900 trillion.
So it kind of sounds almost like this is a little bit of a semantic argument. A zip compression was not designed to be an encryption tool, so it's lacking some of the fundamental foundational features that would make it useful.
Is this the argument with your coworker?
The argument with my coworker is that like he genuinely did not acknowledge a difference. And I would say the difference is that an encryption algorithm provides you with an infinite number of different ways to scramble a message, all of which are as difficult to guess as all of the rest. Whereas a compression algorithm, it might fool me, but it'll kind of be like, I remember when I was a kid, I had a World Book encyclopedia because I'm old, and each letter of that encyclopedia started with this letter in hieroglyphics. And I just memorized all of those different characters, right? So A was a picture of an eagle, and B was a picture of, a hut and whatever. And I could pass secret messages to my friends with that. But ultimately, it's just like writing in cursive, right? Maybe you don't know those letter forms immediately, but like, it's not that hard to figure out. And once you figure them out, you've got them. And like, I need to go back to the drawing board and learn a completely new thing.
The fundamental difference is that a compression algorithm is trying to take data out in order to make, like a series of files or whatever smaller. Like it's predictable compared to what encryption is, which is every piece of this we're rerunning this complicated algorithm on based on this number, and all of this math is based on this number. And if you don't have this number, it's useless to try to solve the math.
Right. And actually a really cool thing about, like a really cool similarity between compression and encryption is that both of them operate by removing patterns in the data, right? Mm-hmm. Like think about if I wrote you a letter and it was just me going, and you wanted to compress it, you would write 3000 A's H, period. Right? And like you just turned like a 3002 character long message into, 7 character long message. Huge encryption or huge compression ratio, because there was like a big, solid, easy to identify pattern in there, and you removed that pattern and just gave me like the shortest version of that. For different reasons, encryption has a very similar effect, which is if there are any patterns in your communication, encryption scrambles them so that anybody looking at it is like, oh, this is just like TV static. There's no information in here. But in fact, if you happen to know the like one number out of a trillion, then you can de-scramble all of that and get a meaningful message out.
I like the pieces you pulled out there. You just listed a bunch of things that very clearly in my head differentiated encryption from compression, even though I do think there still is like there's a deep
They're both
place
jumbling up.
But what I wanted to bring up is actually interesting. I don't know if you guys know this, but another person that we grew up with, Andrew, I don't want to say his last name without getting his approval, but he did a project for a computer science project for his master's, I think, where he looked at encrypted traffic. Let me see if I can get this right. He was looking at encrypted traffic on routers that was exposed that he could, so basically the nonsense, the static that you were just talking about.
Right.
And he was looking to see if you could identify the website that was in that traffic based on like sub patterns within the encryption. And I believe his conclusion was absolutely. You could like tell that someone was looking at Facebook. I couldn't tell you what they were looking at on Facebook,
Right.
but I could tell you it was Facebook's encrypted traffic going over the network.
Which
That's
is
brutal.
essentially the same as if you've seen the Turing movie.
Oh,
They end up
Imitation.
breaking it in the end. Imitation Game. That's what it was.
I have a correction for that movie, FYI.
I like this. I'm hoping that this becomes a bit because I always want to correct stuff. And Kerp got me over it a long time ago, but it would be a really fun piece in episodes every once in a while.
In the Imitation Game, like early on when we're establishing the group dynamics between the like super scientists and stuff, Alan Turing like blows off lunch with all those people, and he has like a single slice of salami or something, and like scribbles in his notebook or whatever while he's designing his, his machine.
Computational
And
engine
like
or whatever.
later, that other prick, I don't know, has like his like tennis sweater like tied around his waist or whatever, and he's like, "You coming out with us, Alan? We're going to the pub," And he boasts like, we decrypted 3 of these messages by doing letter substitutions, right? Which is like, oh, they use this character the most, it's probably an E, right? And then like we check E off our list and like go through. He says that they did that. Totally not true. That's not the crazy revolutionary thing about the Enigma cipher was everything changed every character, right? So an E wouldn't be represented by the same other letter all the way through. And if they had, solved 3 messages using this like substitution stuff, they would have solved all the messages for the day because they would have had to get the actual key. So anyway, I really wanted to like that movie, and I was really angry that happened.
I remember spotting an error in that movie also, but I can't remember what it is, so I'm going to assume that maybe
Was
it
it
was
that
that
Natalie Portman was into Alan Turing?
Is it true? Is it historically accurate that the word substitution was, or not substitution, but you know what I mean? The pattern
use the
recognition
sign
was
off?
Heil Hitler or whatever it was.
I think I looked
Is how
that
they
up.
No,
got it?
actually, one of the things that did allow the Allies to break that cipher was the Nazis were total Nazis about everything, and every single morning at exactly 6 a.m., they sent out a weather report that had exactly the same format. And I bet this is similar research to what Andrew was doing with like, is that encrypted traffic Facebook or what? Is like, because the underlying structure of that message was so rigid, even in the encrypted data, there were sort of like structural similarities that we could like hang on to and like really reduce the number of combinations we had to try.
Do you want to do Sacagawea coin?
Yeah, let's lighten it up because this has been like
Okay,
real.
so-
It's been pretty deep for a hit list.
Beyond corrections, there's another bit I call it a bit like I'm a comedian and I know what I'm doing. There's another hit list topic that we've tried a couple of times and they just weren't right. And I
should
ended
have
up
been recording it in your Honda Pilot
right.
dozens of times all those many years ago, whenever anyone gave you a Sacagawea dollar as change.
So the hit list item says Sacagawea gold coin, right? It's $1 gold coin. Is that what it is?
It was a $1 coin. I worked at a bank at the time, and people always, like, old ladies would come in and ask how much they cost.
So whatever year that was, I don't remember.
That's what you
In
told
our
him.
childhood, they announced that they were doing away with the Susan B. Anthony silver dollar and replacing it with a gold dollar. And there was and it was in the headlines for a while that they were trying to pick like what was going to go on this coin. And they ended up picking Sacagawea. Anybody want to take a stab at explaining who Sacagawea is? I believe she's the Native American woman that helped Lewis and Clark get like through the wilderness
That's true.
to make
She
it
was
from
Lewis and Clark's guide.
Yep. Nailed it.
Anyway, so they put her on this coin. And at the time, for me, it was like the only piece of currency that didn't have some sort of political leader on it. And it made me grumpy about I'm trying
how white
to
men are being displaced from their proper place.
Yeah, basically. I was, I'm having trouble recounting it because I don't want to sound like the asshole that I was about the existence of this coin.
When you were a teenager?
I have to tell your listeners, Kerp actually texted me, Adam actually texted me, I don't know, it must have been
This is
2
how
or
it
3
ended
months
up
ago,
on
is
the
when,
list.
when Harriet Tubman got named for the $20 bill. Adam texted me and he said, "You know what? I think I've turned the corner on Sacagawea." And I almost dropped my phone. I hadn't thought about that.
This is what I thought was great. We hadn't talked probably like since my bachelor party. So it had been 8-9 months, and I sent you a text out of nowhere.
Sacagawea since
in 15 years.
college.
Yeah, 10 years. And so I just sent you a text that said, "I think I've turned the corner on the Sacagawea coin," and your response was Harriet Tubman ? Like I appreciated that. I didn't even have to explain it to you. Like you had already put together the logic, what track that my mind was following to get to turning the corner on the Sacagawea coin. But really, though, so they announced the $20 bill with Harriet Tubman on it, and I realized, like, you only get to pick what's going to go on money every so often. And they have an agenda, and they're sticking to it in terms of diversifying just the type of characters that are on our money. Like, never mind. Yeah, Andrew Jackson is a terrible person. I mean, he was a president. It was impressive. But he was also like a murderer. He had a bullet inside his body from a duel the whole time that he was president. This guy was...
His parrot got ejected from his funeral for bad language.
But I also appreciated your props when you said...
Yeah, you're a big man for admitting it. For digging that deep.
That is nice. That's a huge accomplishment, Adam. It's part of the reason that I think we're doing this podcast, too. So it's nice to have a real firm example of your growth.
Yeah.
It's safe to say I had a foolishly intolerant position on the inclusion of...
I think Adam's analysis of the situation at the time was that white dudes were out and diversity points were in.
Diversity points. That's what I think is important, right? It seemed like a bullshit PR grab, right? It was like they didn't explain it in a way that made me be like, yeah, that's an important person. But at the time I didn't understand it. They didn't explain it to me. And we were like 16, right?
Also, we were 16-year-old suburbs.
Who was grabbing the PR in this situation?
But somebody's in charge of writing
US
a document that goes out announcing that this coin is going to exist. The U.S. Mint or something, right?
Do you think it's the people that when I just searched for Sacagawea on Google, the people who are promoting the sexy Sacagawea costumes that come up in like the top 20 searches?
Top 20
I would say
hits.
zero overlap. Well, I was certainly too solipsistic to recognize how they were talking about it, what messaging was
I
attached
know
to it.
that term solely because you came to understand that term long before anyone else I would ever talk to.
Wait,
I remember
which
you
term?
telling me about
Don't you have a
solipsism.
philosophy degree?
Dude, that's what. Yes. So you would explain to me things like. So, do you want to explain what solipsism is first?
Oh,
Wait, say it again. Solipsism?
solipsism.
Solipsism.
Um,
Is that a C?
Solo.
CIS?
my perspective as a teenager was solipsistic, and it sort of comes down to the idea that, like, okay, ultimately nobody can convince me that they exist, right? There's like,
Uh-huh.
if you posit that there's like a wizard who has my brain in a jar, I guess he's a scientist wizard, and he's like beaming experiences at me, then literally nothing you do could actually convince me that you exist. I know that I exist because I'm having the experiences that I'm having, but nothing else could, we're all grasping at epistemological straws.
Mhm.
You explained this to me in 6th grade. It would not come up again in a conversation that wasn't with you until I was a junior in college, studying philosophy to get letters after my name.
I found that this was a really fruitful for a brainy kid who was in an all-boys school full of people who didn't like him. This was a reliable way to get a rise out of.
It's good to have tools to know the people that you're just like, this is just not going to work out.
Yep.
Sorry.
Ways to judge. They might as well be T-shirts, because then the
Yeah.
person can at least choose to wear a certain T-shirt.
Okay. I feel like that's as good a place as any to get out of this one. Thanks for hanging around for another one of these, and thanks for hanging out, Alan.
Yeah, thanks for having me, guys.
I keep racking up the corrections. We'll make this a
I'll keep
regular
paying
thing.
attention.
Yeah.
We're
Thanks for
missing-
Patreon.
I'm
backers,
Adam. I'm Brian.
everybody else hanging out. But
I'm
this
Adam.
is Engineering.
I'm Ryan. I'm
I'm
Alan.
Adam.
Find us where you found us, which is useless, but it has grown on me. Now I like it.
Full circle.
What? I'm assuming that you're just going to retry whatever brought you to us the last time you ended up listening.
It doesn't really matter anyway, because none of you really exist. So
Right. I'm Adam
I'm Ryan.
I'm Alan.
Jones.
Oh yeah, if you're out there and you're not just a figment of my imagination, I hope you have an awesome night.
Good seeing you, guys.
They don't know what I know.
This
I'm
podcast.
generally pretty paranoid. I just don't think anyone cares what I'm up to.
I would imagine that as a parent, you can only worry about so many things, so you've got to just default to some like, hey man, here's some standards. I haven't really thought them through, but you're gonna live by them.